Good morning to us students. Today I will be discussing the organic chemistry part 2 with you guys. So sit back, relax, and enjoy the ride with me. Let's start with the alkyl groups. Now before we do that, let me just recall the difference between a branch and the main chain. The main chain, ladies and gentlemen, contains the longest continuous carbons bonded to each other. The branches are the groups or atoms that are bonded to the main chain. Now let's discuss the alkyl groups. Alkyl groups, they have the general formula of CnH2n plus 1. We have methyl group, its structural formula is CH3. Ethyl group, it's CH3CH2 or C2H5. We have N-propyl or simply propyl without the N. It's CH3CH2CH2 or C3H7. And isopropyl, it's also C3H7, but I want you to notice the difference between propyl and isopropyl. The propyl, ladies and gentlemen, we have the carbon on the extremity or at the end of the group. This carbon is bonded to the main chain. While in the isopropyl, as one can see, it is the carbon in the middle that is bonded to the main chain of carbons. Next are the halide groups. Halide groups are the group of atoms that belong to the halogens in the periodic table. So if you have a chlorine that is bonded to the main chain, we call it a chloro. If we have a bromine, we call it bromo. If we have fluorine, we call it fluoro. And if we have iodine, we call it iodo. Now let's look at this note on the slide here before us. Alkyl groups and halides are branches that are bonded to the main chain of carbons, but when naming the branches, the halides gain priority over the alkyl groups. What is meant by gaining priority? If we have a chain of carbon that contains both halogens and alkyl groups, you must name the halogens first, then name the alkyl groups next. Now this is one of the most important slides we have for you guys to study. This slide has the rules for naming an organic compound. Number 1, or remark 1 or rule 1 if you wish, the student must mark or recognize the main continuous chain of carbons, which is simply the main chain of the organic compound. We need to identify the branches. We need to number the main chain of carbons in a way to give the branches the smallest numbers possible. We need to apply alphabetic priority in naming the branches. Alphabetic priority means that if we have methyl and ethyl, you should name the ethyl before the methyl simply because in the alphabet the E comes before the M. We need to use a comma to separate between numbers. We need to use a hyphen or simply a dash to separate between number letter or letter number. Lastly, we need to use di, tri, tetra, penta if we have 2 or more of the same kind of branches. What is meant by this rule? Let us just consider that on the main chain we have 2 methyls, so we have to write down dimethyl. Let us just consider that we have 3 ethyl groups on the main chain, then we have to use the prefix tri. Let's start some applications on naming organic compounds, ladies and gentlemen. We have the structure here before us to simply name. The first thing you have to do is locate the longest continuous carbon chain. Now, the longest one in this structure is the one that contains 5 carbons. Next, we need to recognize the branch. On this main chain, we have only one branch, which is an alkyl group by the name of methyl. Now, we need to number the chain in a way to give this branch the smallest number possible. We have numbering from left to right and from right to left. Left to right is done using the red numbers, and right to left is done using the green numbers. Now guys, as one can see, if you count from left to right or from right to left, the methyl group will just simply get number 3 on the carbon chain. So in this case, you can simply number the chain using the left-right sense or the right-left sense. It doesn't matter, only because the methyl group in either direction gets number 3 on the carbon chain. So the name is as such. We write down 3 to indicate that the methyl group is located on carbon number 3. Now, why did we place a hyphen between the 3 and the M? In the rules given previously, when you have a number and a letter, you have got to use a hyphen to separate between them. So we call it a 3-methyl, and we write down pentane, which indicates the name of the parent chain or the main chain that happens to have 5 carbons. And the reason why we called it pentane is because it has 5 carbons, and between these 5 carbons we have single bonds, therefore it belongs to the alkane family. Another example here for you guys to name. We have this structure here before us. First off, we need to locate the mother chain. The mother chain is the one that contains 6 carbons. Now, we need to recognize the branches that we have. As one can see, we have 2 methyls indicated by the circles, and we have 1 methyl that is placed in a rectangle. Now, the sense to be used in naming this chain is from right to left, so that we can give these branches the smallest numbers possible. Now the naming, since ethyl begins with an E and methyl begins with an M, we need to apply alphabetic priority. So we write down 3-ethyl to indicate that the ethyl group is located on carbon number 3, and then we put hyphen 2, 4, hyphen dimethyl to indicate that we have 2 methyls. Like I pointed out earlier, when you have 2 or more of the same kind of branch, we need to use the prefixes di, tri, tetra, etc. Since we have 2 methyls and they are of the same kind, so we have to use dimethyl. But where are these 2 methyls located? They are located on carbon number 2 and carbon number 4 on the main chain. Therefore, the entire name of this structure is 3-ethyl 2, 4 dimethylhexane. Remember guys, the hyphen is used to separate between letter number or number letter, and the comma is used to separate between numbers. One more application please guys to pass along to you. Here we have a structure that contains the methyl group, which is CH3, and it contains 2 bromo halide atoms bonded to the main chain. Now of course, when you have alkyl groups and halide groups or atoms bonded to the main chain, we need to give priority to the halides to name them first. So we start counting from the right side. We have 2 bromos bonded to the main chain. These 2 bromos are our carbon number 2 and carbon number 4. So we start 2, 4, hyphen dibromo, hyphen 2-methyl pentane. Now as one can see, we started the naming of the halides before the alkyl groups, and we counted from the right to left, not from left to right, only because In doing so, these groups will simply get the smallest numbers possible on the main chain. To recap the name, it's 2,4-dibromo, which means that we have 2 bromo atoms bonded to the second carbon and to the fourth carbon. And of course, the methyl is located on carbon number 2, so 2-methyl pentane. Now we need to give you a couple applications on isomers. Like I explained before, isomers are structures that have the same molecular formula but different structural formulas. Let us, you and I, examine the isomers of pentane. Remember, these isomers, they all have the same molecular formula of C5H12. The first one is when we simply line up the carbons in a straight chain, and we call the first isomer pentane. Now, to start drawing the isomers, we simply drop the number of carbons in the chain by 1. So in pentane, we have 5 carbons. You drop this by 1, you end up with 4 carbons. Now you need to place one more carbon. Never ever place the carbon on either extremity, because if you do that, then you would just go back to pentane. So you can place the 5th carbon on either the second or the third carbon, it doesn't matter. And the name of this isomer is 2-methylbutane, simply because the main chain has 4 carbons and the methyl is located on the second carbon. Now if you choose to place it on the next carbon in the middle, it will still be 2-methylbutane, simply because if you started the counting from the left side, you end up with 2-methylbutane again. Now from the 4 carbons, we drop the number to 3, and we need to line up 2 more carbons. Like I said, you can never place carbons on the extremity or the 2 ends of the main chain. So you only have 1 carbon in the middle to place groups or carbons to it. So we place 2 methyl groups on that carbon. Now the main chain is the one that simply has 3 carbons in it, so it's propane, and we have 2,2-dimethyl, meaning that the 2 methyls are simply bonded to carbon number 2 of the main chain, which happens to be propane in this case. Those guys are the only isomers that we have of pentane. Now let's look at another example. We have the isomers of hexane here. We start with the one that has no branches, so simply it's called hexane. Now from hexane we drop to pentane, and we have 1 more carbon to place, so we place it on carbon number 2, and the name of this isomer is 2-methylpentane. Now in the pentane chain, we can place the last carbon on carbon number 3. So we have another isomer, and the name of the third isomer is 3-methylpentane. Now when the options with the pentane are all over, we move down to butane. Once you have the butane as the main chain, you need 2 more carbons to place. You can place these 2 carbons at the extremities of the butane. So we have the second carbon to place them on. So the name of this isomer is 2,2-dimethylbutane. Now, instead of placing these 2 on the same carbon, we can place the 2 carbons, one on the second carbon and the other one on the third carbon. Therefore, the last isomer of hexane has the name of 2,3-dimethylbutane. Now for homework, please, in your book, page 240, numbers 7, 9, 10, and 11. Thank you so much, and God bless.